Hey guys, Larry C here. I'm not one to give gambling advice, but when I do, I always say never gamble on a fart. Shout out to you all. Hope you enjoyed the video.
Come on now, dog. Come on, man.
Hey guys, Larry C here. Shout out to you, Stat Cats. In this video, as promised in my last one, I have something cool that I've been putting in the works for this particular chapter on probability from Elementary Statistics 14th edition by Mario Triola. No, they don't endorse me, but I want to say that. Also, fair use. Shout out to the Coach Gang for teaching me that. But something that I noticed in this chapter was that there are a lot of sidebar remarks and interesting facts and tidbits within the sections of chapter 4. And as you get closer and closer to the end of the chapter, you find that more and more of those sidebar conversations or annotations, those are related to gambling. Okay, so like I think there's a story about the lottery, another one about some other casino game, and I thought for sure that there were going to be a lot of examples to do with cards, because we usually have a lot of examples dealing with cards, get it, dealing, in the online version of the stats course, but I was quite surprised that there weren't virtually any card problems, which I'd be remiss if I didn't do anything related to cards in the statistics course, especially during a chapter on probability. So I thought, well, I'm not the biggest fan of card problems anyway, so I thought that was a great thing. It might be an opportunity for me to dodge something that I don't really like. But as I'm getting older, I'm learning that I need to lean into the things that make me uncomfortable. And so this is an example of that happening. I wanted to lean into my dislike for probability or counting problems related to cards. So I thought, all right, well, this could go very bad or it could go very good depending on my mindset. And I just decided, you know what, how about I gamify things and have a little fun with it, because if I know I'm having fun with it, well, there's a chance that my students might too. So all this to say that to get practice with probability problems involving cards, and to give an incentive to students to practice those types of problems, I want to introduce to you guys Mr. C's Casino. Let me shrink this window down. So this is something that I had Claude help me with, and I'm going to show you the prompts for it in just a little bit, but I'd like to show you guys how this works. So a student should be entering their ID. I'll put in mine just so that we can work out this applet. So I'll just put 6-7. Shout out to my kids for that. And then take a seat. All right. Now, if you look over to the right, 0 out of 10 points banked. And each one of these empty circles will be a tally of how many bonus points you earn here. Now, I asked Claude to give me sort of an introduction page so students know what they're up for. It says, welcome to the house. Mr. C's Casino is an extra credit opportunity built on exactly one idea. The house always knows the odds. This semester, so will you. And the games that I wanted to feature here were two of them, roulette and blackjack. So it says here there are 2 tables. At each one, you don't get to play until you can do the math. Answer a probability question correctly, and the house lets you spin or draw. Okay, so they don't get any bonus points until they've solved the probability problem correctly. How much they get, well, that's dependent on the randomness of the game. But you'll see how I organize the point system. Get it wrong, and you're welcome to work it out again. The wheel isn't going anywhere. So they can get as many attempts at a problem as they want. It says both tables stay open all semester. Play as many rounds as you want at either table in any order, but your combined total from both tables is capped at 10 points for the whole semester. I started out with 4, but then I thought, depending on what my total points for this course is going to be in the fall semester, I might be able to get away with 10 points. So I'll adjust accordingly. But once you reach 10, both tables are closed for good. All right, so the roulette setup, up to 3 points per spin. So each round you'll be asked one probability question about an American roulette wheel. 38 pockets, 18 red, 18 black, 0, and 00 are green. Many of these are compound questions asking about 2 conditions at once with and or, so read carefully. Answer correctly and the wheel spins. Land on green, you get 3 points. Land on red, you get 1 point. Land on black, you get 0 points. Get a fresh question and spin again as many times as you like until you reach your semester total of 10 points possible. So you can max out the 10 points just by playing roulette, or you can max out the 10 points by playing blackjack, or you can do some combination of these. Now, blackjack, it's up to 2 points per draw. Each round, you're dealt a starting 2-card hand, shown face up, total 12 through 16, and asked the probability of busting or staying safe. Pause. On your next card, since your 2 cards are already out of the deck, the correct answer is based on the remaining 50 cards, not 52. So this is illustrating the concept of drawing 2 cards without replacement. Simplification. For this game, an ace always counts as 1. About half the time before your hand is even dealt, you'll get a quick before-the-deal question about the odds of a certain kind of 2-card hand, like drawing a pair or an actual blackjack. These use combinations NCR. Answer correctly to have your hand dealt and continue as usual. Answer correctly and you draw 1 card. So you have to do a pre-question before you do a question that gives you the potential for bonus. Okay, your resulting total determines your points. 19 through 21, you get 2 points. 18 or under, no bust, you get 1 point. Bust, you get 0 points. Get a fresh question and draw again as many times as you like until your semester total hits the 10-point cap. All right, so down here just explains the scoring, how you can get up to 10 points from doing some combination of these 2 games, and just a little bit more about details with student ID. So it says, ready to see the math worked out first, head to the study the odds. Ready to play, take a seat. But remember, each table only deals once. All right. So as I was designing this with Claude, I wanted Claude to give some examples. Since there aren't any examples of these in my notes, nor are there hardly any examples of these types of problems in the textbook itself. So it says, here are 4 worked examples, 2 per table, at the same difficulty you'll see when you play. Walk through the reasoning before you sit down at either game. So this is kind of like their preparation before they get themselves a shot at bonus. Roulette example 1, what is the probability that the ball lands on black? Now it states here, an American roulette wheel has 38 total pockets, 18 red, 18 black, 2 green. Since each pocket is equally likely, probability of black is number of black pockets divided by total pockets, which would be 18 out of 38, so number of desirable outcomes divided by total possible outcomes. And reducing the fraction, 18 over 38 gives 9 over 19, or 0.474, about 47.4%. So if they answer this correctly, the wheel will spin. Then here's kind of a more challenging one. What is the probability that the ball lands in the second dozen? 13 through 24. Okay, so there's an explanation of that. And then here's an example using some compound probabilities. So one of the things that happened during the first prototypes of this Mr. C's Casino was that I found the blackjack problems to be much more challenging than the roulette ones. So I asked Claude to increase the complexity. And this is what it came up with, and I'm very satisfied with it. So what is the probability that the ball lands on red and an odd number? So this isn't a name category like red or odd alone. It's asking for pockets that satisfy both conditions at once. Since red and odd aren't evenly matched up on the wheel, we can't just multiply probability of red times probability of odd. We have to count directly. So yes, you do have to go through and count all the slots that satisfy that criterion. So it tells you there are 18 red numbers, and there are also 10 odd numbers of those 18 red numbers. So if we want both criterion satisfied at the same time, we need to look at these 10 and then divide it by the total possible. So there are 10 numbers that are both red and odd. So that'd be 10 over 38 or 5 over 19, roughly 26.3%. There's also an OR type compound probability. For OR questions, count every pocket that satisfies at least one condition, but don't count a pocket twice. All right, so that was emphasized during the guided notes of this chapter, so they should be aware of that. And then they give an example. Of the 18 red numbers, 9 are already in the 19 through 36 range, so they'd be double counted if we just added 18 plus 18. So you can add 18 plus 18, but you got to subtract off the amount that was double counted, which would be 9. So that gives you 36 minus 9, 27 out of 38. So this is a little more challenging than, the first or second example. Then there are 4 examples dealing with blackjack. So your hand is dealt 9 of clubs and 4 of hearts, totaling 13. So since these 2 cards are already out of the deck, what is the probability that drawing one more card causes you to go bust? So that would be goes over 21. All right, so you bust if the new card's value pushes your total above 21. So since 13 plus 8 is equal to 21, you need a card worth 9 or more to bust. All right, so it works out the rest of that. So you get the gist, probability of busting, and then there are a few more. Some get a little more tricky. So like something like this, what is the probability that a 2-card hand from a full deck is a pair of aces? Okay, so the total possible outcomes is 1,326. That's 52C2. Favorable hands, we need to choose 2 cards, both from 4 aces. There's no second group to multiply by this time, so you would have to do 4, choose 2, and then you'd have to do this combinatorics calculation, and then divide by 1,326. Okay, so it's about a 0.45% chance. All right, so after the student has entered their ID, they can go through all these tabs, but they need to enter the ID before the take a seat section is loaded. All right, and so it says here, take a seat, pick a table. Remember, each one deals just once per semester, which that might need to be modified because that could just tell the student that they only get one chance at each. So I'll fix that later. But here's the roulette one. Okay, so roulette question, what is the probability that the ball lands on a number from 1 through 18 and an odd number? All right, so I'm going to pause the video for a moment so I can work this out, and then we'll see what happens afterwards. Okay, so I'm getting roughly 0.237. Let's hit submit. And because that was correct, the roulette wheel spun, and ball lands on 29, black. So no bonus points, so they'd have to spin again, okay? So that kind of resets things, and then they get a new problem to try. They enter it in, and then hopefully, it lands on a shaded area where they get bonus points. So, it could take some time to rack up some of these bonus points due to, how the areas are proportioned with the roulette thing. So that's how the roulette works. Next, the blackjack. All right. So blackjack question, your hand is dealt 7 clubs and 9 hearts, totaling 16. Since these 2 cards are already out of the deck, what is the probability that drawing one more card does not cause you to bust? Okay, aces count as 1. So you want to make sure that you, draw a card that is not 6 or higher. Okay. And this is going to involve a counting principle, the NCR rule. And I'm going to pause the video. Maybe you should too, to see if you can work this out, and then we'll check it together. All right, so I'm coming up with 0.4 right on the dot. Let's see if that works. All right, so I got that correct, and I drew the next card. Oh, and I drew a jack of spades. So that caused me the bust, so 0 points. Okay, so these aren't necessarily freebie bonus points. They actually got to do some work towards them. So you could draw again. And then you get a different problem, which you'd have to calculate the probability for. And then your hand is dealt a queen of diamonds, 4 of clubs, totaling 14. So since these 2 cards are already dealt, so what is basically telling you there is that you got to do 50C1 as the total possible outcomes for the next draw. What is the probability that drawing one more card causes you to bust, so goes over 21? The previous problem, you had to select cards that don't make you go over 21. So it's nuanced a little bit. But anyway, that's kind of the gist of it. I'm still going to have to figure out how to link the player ID to, let's say, like a Google form where it keeps track of their points so that I can enter it into the gradebook accordingly. But, this is something that you're welcome to use if you'd like it. Let me show you how this thing evolved. So again, this is my solution to there not being really many card examples in the chapter 4 of the textbook I'm using, as well as a bonus point opportunity and, dare I say it, a little level of fun. But I started with greetings. I have kind of a big and complicated request regarding an idea I have for my stats course I'm creating. Of course, it's like, yeah, I'd be happy to help. So I said, right here, I'm kind of setting the stage. The level is first-year college students, and the course is Math 122. Not sure that Claude would understand what that means fully, but it's asking some follow-up questions. What's the deliverable? What's the big and complicated idea? And are there any constraints? So I had this prompt, all right? So I tried to get as detailed as possible. 9 times out of 10, it's not going to work perfectly, so you just have to keep iterating. I'd like to create a mini casino called Mr. C's Casino where there are 2 simulations. The first is roulette and the other is blackjack. I'd like both to be opportunities for students to earn extra credit. Specifically, I'd like you to provide an appropriately designed level of difficulty problem in which they have to correctly find the odds of winning. If they answer correctly, they get to earn a spin or draw a second card, or third card in this case, for blackjack. I started with 0, 1, or 2 bonus points as the possible slots for the roulette wheel. And then for blackjack, I really wasn't sure how to tier the different bonus points. So the win bonus, but I'm having trouble determining a similar criterion of that of the roulette. The maximum number of points that can be earned is 6 between the 2 games, which, as you saw, I adjusted to 10 points. So it said, yeah, I like the idea. It's a fun concept. And then it recommended this as the overall structure. So roulette, maximum of 2 points. Blackjack, maximum of 4 points. Combined max, 6 points. And it said, it follows this logic, answer a probability question correctly to unlock a random event. The outcome of that event determines a point payout. That's exactly what I wanted. So it broke down some probabilities, some expected values, and things of that nature. And let's see. It said, okay, happy to build an actual interactive. If you want students to play it digitally, just let me know the format you're picturing. I said, I love it so far. Yes, I'd like this to be digital. The 6-point cap is per student for the semester. Also, I'd like an introduction as to how the casino works, what they're expected to do, and some sample examples with fully worked out solutions for them to learn from before playing. So you want to imagine yourself as teaching this as a lesson. So you need to provide that background information and some examples so that students can follow and find success with these 2 games. So it asked me another design question. Let's see. So it gave me the first round of the casino. Let's see if I can show you that. Looks very similar to the one that I just showed you with examples. But what I found was that the roulette problems were far easier than the blackjack problems. So after doing some back and forth, and another thing I found is that I had to specify that I did not want this part of the roulette. So I had to just mention that I only want the roulette wheel. Okay. I'm honestly not really sure how that works, but I do know how the wheel works. So So it took care of that. And then I kind of went back and forth a little bit with the scoring system in terms of bonus points, and it did as I requested. But I thought, okay, are these point assignments fair in your opinion, or would you recommend something else? So what did I do? I said, can you make the blackjack up to 3 points per draw, please? And so it did. But I didn't want any hubris, so I asked if it thought it was fair to do that. And it said, let me actually run the numbers rather than eyeball it, and it did expected value, which I thought was a smart move. And my honest read, no, I don't think it's quite fair as is, and it's actually a bit worse than before your last two changes. So I over-engineered it. It says 0.844 expected points per successful round versus roulette's 0.579. So that's roughly a 46% difference in terms of payout. Okay, so it gave me a couple of options: nudge the roulette's payout up, or trim blackjack's tiers again. And it said I'd lean toward a small dose of both rather than a big swing in either direction. And I said, I agree, let's do a small dose of both. And it made the changes, and it kind of closed the gap a little bit. Let's see. The gap is an expected value per successful round shrinks to 46% down to 21%. So I thought it was a reasonable resting place, given blackjack's questions remained the harder ones to answer correctly in the first place. So I thought, fair enough. Gave it a little compliment, you're the best, and said it's having fun making this with me, yada, yada, yada. So anyway, that is my, take on how I would handle the, fix of there not being many probability questions dealing with cards, which I wanted to avoid at first, but I knew I shouldn't. So in that case, I thought I'd make it something that's fun for both students and myself, and also an incentive for them to actually do it. All right. So if you have any questions, let me know. If you'd like me to send you the HTML file, let me know. Otherwise, thanks for sticking in and watching with this. And I will see you in the next video, Stat Cats. Let's keep bossing up. Shout out to you all.